just went outside and I got ready for the next part of the experiment. Look at this. Whoa, a big bowl of snow. Now, let me just tell you this. If you don't want to get snow, you could use some ice for this out of the freezer. But snow's easy to use and get to this time of year, right? Right. But anyway, especially right now, this time of year, this year, right now, good for snow. Yeah. But anywho, I went out and got this big thing of snow, and I want to hurry with it because what I'm going to do is I'm going to get, sorry, bad camera work. I'm not a good camera person. Okay, so I'm trying though. See, this is why those YouTube people, they get rich and they hire camera people. You know what I'm saying? I ain't got that yet. Like, I am just here doing this remote NTID day stuff, okay? No extra cameraman. But anywho, I got this whole thing full of, look at that. It's full of snow. And I didn't compact it or anything. I just kind of like scooped it in there and got me some snow. It's already melting. It's going to melt really fast in front of that fireplace. So I got to hurry with this. Now, the second cup, I'm going to fill all the way, but I'm going to push it down. Push it down. And I'm going to try to compact it a little bit more than the first one. We'll see if I can do that. Let's try. I'm going to try to push it down. Push it down. I don't really want to melt it. I just want to kind of push it down. Try to get as much in there as I can. Okay, now I'm going to set both of those right here. Ooh, that first one's already going down. You know, I really liked some of your videos the other day with the salt and the melting. There were people who did like that little like fast photography stuff. The little, oh, it was so good. I really enjoyed watching the videos and seeing all your pictures. Now, I said take a picture of each part of this lab, but I understand, you know, some of you may not be able to go outside and get snow today or whatever. I get it. And you're going to have plenty of time to do this. You know, it's not just, you don't have to have it done just today. If you want to do it over the weekend or next week, that's okay too. But if you post 2 pictures, 2 experiment pictures, that's extra credit for the second one. So if you do 1, that's your points right there. You'll get a good grade. If you do 2, it's for bonus points. So just watch both parts, and obviously you are, because here you're watching me right now. But watch both parts and understand what I'm doing in this experiment. Because tomorrow there will be some questions and I'll put some, you know, little things on paper about what I've said and done today. That way, if somebody wants to just read instead of watching me, then they can do that. They can just read it tomorrow. But the whole point of the second experiment, again, we're looking at density of substances, solid, liquid, gas. But in this part, I really want to focus on water because water is a special substance. And because water is special, you know, most substances are most condensed. The molecules are the closest together when they're a solid. Not so with water, because when water becomes a solid, its molecules spread out. That's why we get these big beautiful snowflakes and ice crystals. When they do that, when water molecules form into the crystals, they spread out a little bit. So you've got liquid water, and the molecules are, you know, spread out about this much, we'll pretend. And then when it freezes, they spread out a little bit more. They're less dense. Water is less dense when it freezes, when it becomes ice. And that's why ice forms on the top of ponds and animals can live down below in the winter. That's why your ice cubes float in your drinks because they're less dense than the water. You know, we learned all that density column stuff where if something floats, it's less dense. So ice is less dense. Now, here's the thing I want you to think about. You know, in this whole weather forecast thing, when they're going, how much snow are we going to get? How much ice are we going to get? I like to watch Brandon Butcher. Definitely. And he's debating, you know, he's given all the latest forecasts. How much ice, how much snow, how much rain. Did you know that 1 inch of rain can equal as much as 13 inches of snow? 13 inches. So, you know, it's a big difference between if you get rain or snow. It's all about, you know, the temperature in the atmosphere and all those things. But 1 inch, that much of rain could be 13 inches of snow because it's that much less dense. It's not as compacted. Now let's check back in, shall we, on our little experiment over here. Ooh, ooh, it's melting. It's melting. The one that I pushed down isn't as melted. I would guess probably because I made it a little more dense, yeah. They're both at the same temperature. That's a constant. They're both at the same temperature. They're both in the same kind of cup. I brought them in from outside at the same time. So there are lots of constants here. The only difference, does that sound like an independent variable or what? The only thing I changed is I pushed this one down a little more. It's a little more like that ice. Oh my goodness, all that ice on the road that just won't melt. But then you got this snow. It wasn't as compacted. I didn't push it down any, and it's melting a lot faster. A whole lot faster. Now, I'm not going to do it right now, but what I want you to do at home is take this snow, if you did this part of the experiment yourself, I want you to look and see how much water you get. You know, you may even want to put a little line on your glass or something on there so you can see where it started. Of course, I know where it started because I filled them up about there on both of them. And this one's just already going down that much. But you might want to put like a line where it started and then see how much it goes down. Because remember, there's going to be a whole lot less water in the bottom than there was snow up to the top. Now, it's still the same substance. It's just a physical change. It's still water. It's just water in its solid form or water in its liquid form. But when it's in its solid form, it is spread out. Even when I compacted this, it is spread out so that when it turns into water, there's going to be less. It's going to go down because the water is going to be a little bit more compacted than the solid form of the water. The liquid form of water is going to be just a little more compacted than the solid form. Now, like I said, two pictures, that kind of look like one, two pictures of your experiments. If you do one of them, then you get the full credit for today. If you do both, extra credit. I like a little extra credit. Don't you like a little extra credit? I like a little extra credit. And then tomorrow we will have questions and a worksheet to go with these activities. Have a great day. I do miss seeing all of you at school, and I hope to see you again very soon. And I hope you guys are doing well, you're staying warm, and you're having a little bit of fun on these NTID days. Bye-bye, guys.